Welcome to my projectbazaar.com. Let us discuss about the 3D brain atlas reconstruction using deformable medical image registration. So application to deep brain stimulation surgery. Let us discuss about the abstract of the product. So in the segmentation in medical images were more helpful for the identification of the disease portion in the images. So the pre-processing step is the first step of the segmentation process. So in the pre-processing step we using the median filter. It smoothens the overall image and makes the intensity or overall image is normalized. So in the clustering process we using the k-means clustering. So it is employed for the images based on the k-means process. The skull region were they removed from the images based on the clustering operation. So the thresholding process is employed for the segmentation of the tumorous portions in the input image. So that is in the medical images. So the level set segmentation process is employed for the segmentation of the tumorous portion in the input images. So finally we calculate the segmentation of the tumor by using the level set images. So the overall performance of the process is measured based on the performance metrics like true positive, false positive, and true negative, false negative, and then also accuracy, precision, recall. So the overall performance measure by calculated by using these all the characteristics. So these are the abstract of the process. This is the overall flow diagram of the process. First of all, taking the input, and then the main steps are there are 4 models. First of all, they're taking the input, and then pre-processing, and then segmentation, and finally calculating the performance measure. So these are the overall flow diagram of the process. So in the input image, we taken the MRA dataset. So that is a brain extraction of the input dataset. By using the input, the pre-processing is applied. The pre-processing step, we using the median filter. By using the median filter, the image is to be taken smoothness, and then again that the process is get to the clustering. By using the clustering concept, using the k-means clustering, so the skull region should be removed, and then the segmentation. So in the segmentation process there are 2 types of clustering are used. One is a k-means clustering, another is the thresholding process. So the clustering process, we remove the skull region of the brain for extract the images on the thresholding. So in the thresholding process we using the levels and segmentation process. By using the levels and segmentation process, we can easily relate the process of the particular image of the tumor. So the tumor portion will be easily extracted by using the threshold. So that is a levels of segmentation. So the tumor, by using the segmentation process, we can calculate the tumor portion of the region in the particular input images, and then also we calculating the what type of disease will be occurred in the brain, and then wherever it is calculated, the k-means and then thresholding is very important to calculating the tumor portion of the process, and then we can finally calculate the performance measure by using the particular input images. So that is a true positive and negative, and then false positive and negative. So by using the true positive and false positive negative, we calculate the accuracy, precision, and recall. By using the accuracy, we calculate the overall performance accuracy in the process, and then the precision. So it is a formula is based on the true positive and negative, and false positive and false negative. So by using this formula, by using calculating the precision, and then finally we calculate the recall. So in the recalling process, that is also the same process. We're using the TPDN and then FP and FN. So these are the overall performance of the process. So these are the overall flow diagram of the particular process. Let us discuss about the running procedure for the product. So click the main file and then run. So it will execute. It take us some time to open up the running procedure. So in case it will be open, we will take the input image by using the data set of the process. So and then we proceeding the overall process, that is a pre-processing step, and then clustering, segmentation, and like that. So now the input images it will be open. So by using these are all the input images. So these are the different types of input images like the DCM. So I will click open the 6 file and then open. So this I will select the 6th image of the in the data set, and then the input image it will be open by using the data set of the process. This is the input image. I will select the input image that is taken by the 6th image. So this is the MRI image of the input images, and then so this is the pre-process image. So in the pre-process image we will using the median filter by smoothing of the process. So compared to the input images, so it will be smoothened, so the noise will be reduced for the pre-processing step by using the median filter of the process. And then in this figure, by using the k-means clustering, image label cluster index may be selected. Expect the tumor region. So expect the tumor regions, all the image labeled by the cluster in the images. So by using the clustering of the operation. So the next figure, by using the next figure, this is also a k-means clustering. By using the different type of k-means clustering, and then to identify the tumor of the brain. So by using this and this one, so the both are the images by using the k-means clustering of the process. So and then removing the skull removed image. So in the skull removed image process, by using the pre-processing step to remove the skull of the brain region for exactly to identify the tumor of the brain operation. So that only we remove the skull in the process of the brain. So this is the skull removed image of the process. So and then counter gluing. So the counter gluing is calculated by the image region by using the brain at lab. So there is a tumor part will be deducted, and then how the tumor will be growth or upgraded by using the tumor growing. So the counter growing by calculating the tumor region of the diseases by in the brain tumor. And then another was segmentation is thresholding. In the thresholding process, we using the levels and segmentation images by extracting the tumor. So all the images, all the brain images are removed, and only the selected the exact tumor region of the part, and then calculating the level set by using the level set segmented images. So that is the thresholding of the one type of a process. So and finally calculating the performance measures, that is a true positive, true negative, false positive and false negative, and then accuracy of a process, and then precision recall. So the overall process of the true positive is 98.912, and then true negative was 2.5586, and then false positive and false negative should be 0 and 58. So calculating the accuracy is 99%, and then precision and recall is 199%. So the overall performance measure calculating by using the formulas of true positive, true negative, and false positive and false negative. So this is the performance measure of the process. And then finally we will calculate so which region it should be deducted. So there again is the tumor region. So I will select the in the first step I will select the sixth image of the data set. So the again is tumor image is the sixth. So the result should be 6. So the number of the total pixel is identified. White and black spaces. So the ratio and area. This is the tumor ratio and the area of the process. So these are the overall running procedure for the products. Thank you. Thank you for listening this video.